Alright, getting back into it here. You can see we got some new wallpaper. What's this new wallpaper? This new wallpaper has a picture of some guy, and it says, "Your mother is so fat. The recursive function computing her mass causes a stack overflow." Now, if you have no background in computer programming, that may not make sense to you, but trust me, not only is that funny, but I almost fell out of my chair when I first read that slash saw this picture. I apologize if it's not super high def. Uh, you may not be able to see it if it's on if it's on low res or something like that. Let's see if we can screw around with this. Do that. Let's stretch it. There we go. We don't want to do that. Let's fit. That's what we want to do. Save it. Let's close it. Now it's all pixelated and whatnot, but still, your mother is so fat, the recursive function computing her mass causes a stack overflow. It's absolutely hilarious. So yeah, go back into the browser. You can see I'm screwing around on Giant Bomb. A little bit of the morning thing, some comments, some stuff. My username. It's a great website. Big fan of Patrick Klepek, as I've talked about in one previous video, and I also a big fan of Vinny. Pretty much the whole Giant Bomb crew. I'm a big fan of. So we'll close that. I'm starting to go through the playlist of the videos I've uploaded, doing some description stuff. So there's that. We'll bring this out. We were talking about pointers. So what are we gonna do here? We've, sort of talked about pointers a lot. We're gonna jump back into Python here. We're gonna try. I have not usually whenever there's a time where I try and illustrate a concept and I haven't tested it before I start recording the video, I make it a point to illustrate that. This is one of those times. I have not tested this at all. We're just jumping straight into this because to me, I think it's important that we illustrate that the concepts that we're talking about are concrete and that we can demonstrate them in a very predictable way so that anyone who has any doubts about the sort of things that we're talking about, that they can know without any shadow of a doubt that we can produce predictable results and we can do it as many times as we want. So how are we going to do this? Well, we've been talking about pointers. So let's attach cheat engine to this Python interpreter. Or let's cancel that real quick. So let's talk about this for a second. We're gonna use Python again. Yeah, we're gonna use Python again. So I don't know. Maybe some people might have a problem with that, but that's all we're gonna say about that. Yes, we're gonna use Python, and the reasons why we're gonna use Python have been articulated fairly well because we can control values within the context of a Python interpreter or any programming language interpreter. Uh, in a way that games do simply just do not offer the ability for us to do that, or simply don't offer us the that measure of control. So how are we going to do this? Well, I kind of have an idea brewing in my head where we're going to start using some of the tools that Cheat Engine provides to find pointers, and there's there's different ways that we can do this. We are going to go with there's two basic. I mean, there's more than two ways, but there are two general, well defined, well accepted ways that you can start digging up pointer values and multi-level pointers and things like that. We are going to go with the easy one first, and then from there we will jump into the more manual method, as it's sometimes referred to, about how to find actual, by using the value box and things like that. How are we going to do this? We're going to use the pointer scanner. Now, what is the pointer scanner? It is a feature of Cheat Engine that, on some basic level, or that's not what we want to say. What we want to say is that the pointer scanner in Cheat Engine is a tool or a feature, or it's kind of almost an application unto itself. But for our purposes, it is a feature of Cheat Engine that abstracts away having to deal with multi-level pointers, as we illustrated in the previous videos about, you have a pointer to a pointer to a pointer, and it quickly gets totally out of control with bit patterns and things like that. you quickly find yourself in the realm, you're off by 1 byte, or, let's be even more pedantic than that. You're off by 1 bit, and you quickly find yourself in some region of memory where you're not supposed to be, and, your application might crash, or you're going to get incorrect results, and then you're going to sort of, do a couple steps after that, and you're gonna be basing those couple steps after that on incorrect results, and it's gonna be a nightmare. So why are we using the pointer scanner? Is because we don't know what we're doing? No, we're using the pointer scanner because we can illustrate how to we can illustrate the concept of what we're trying to do with Cheat Engine and find pointers relative to a Python interpreter instance in a much easier way than we can by digging through multi-level pointers of a Python interpreter. And specifically, or non-specifically as the case may be, Python is a very high level language. The sort of C code and whatnot that's written that defines how this stuff, how the language works under the hood, is incredibly complicated, and we're not about to dive into that. Or I'm not about, every time I say we're not going to dive into something, we wind up diving into it. But this I'm fairly certain that we're not going to dive into what Python's really doing under the hood. Why does Python under the hood have 10 levels of indirection or something crazy like that? There are very technical reasons why, but we're not going to concern ourselves with any of that. We're simply going to say that when we declare a variable in Python, it's not doing a straight assignment. So when we do this, which is something that we should be very familiar with at this point, when we do an assignment statement like this is not just under the hood. There's the intermediate memory manager here. It's doing all kinds of black magic. What we're really doing here is we are not simply assigning a constant to a value. There are multiple levels of indirection. Oh, that's a lot of dings. Let's do that. Well, we can't do that because obviously, but when we execute this statement, there are really many levels of indirection going on here where there's some value here, and then there's some other value here, and there's some other value here. We're just making this crap up. Some other value here, some other value here, and then so when you refer to the variable x, there are multiple levels of indirection going on before you actually get to this value 5, and that sort of those multiple levels of indirection is directly a result of how Python implements that kind of stuff. So in order to get around that sort of complexity, we're going to use the pointer scanner, and it works to our advantage because, again, the pointer scanner is going to abstract away some of the details about how to deal with multi-level pointers and whatnot. So let's sort of dive right into that. So we're going to restart Cheat Engine. We're going to close that. We're going to close the Python interpreter. We're going to restart the Python interpreter. I'm going to put it back up here in our little box. We're going to have to minimize it for a second. Open up Cheat Engine. Yes. Open this back up, or bring this back up, as the case may be. We're going to set a variable. We're going to create a variable. What are we going to? We're going to call the variable Bugs Bunny. We're back into the realm of humorous variable names. What's the value going to be? We want this value to be. We ideally what we want is we want to set a value to this variable that has enough randomness or entropy or whatever you want to say in the value or in the bit pattern that represents the value that we're only going to get one result back. So let's see if we can maybe do something like that. We're going to do 9 5 1 8 2 3 7 4. Now we have to attach Cheat Engine to the process. Again, we're not going to choose the first Python process here. We're going to choose the second one. Your mileage may vary with this sort of approach. How do we know which one is which? We don't really. There's two Python processes pretty much on Windows all the time, as far as I can discern. And as far as I can tell, choosing the second one's definitely the better bet. So we're going to do that as far as this video goes. And does it mean this is absolutely going to work for you? No. You may wind up having to choose the first one, and in that case, then just sort of reverse what I'm saying. But anyway, we're going to pretend the second one's there. So what is the value? 951 82374. There's only one value. That is some crazy, ridiculous bit pattern. So we're going to do that. So we found, or have we found the value? I don't know. Let's make it 0. That seems reasonable. Let's ask Python, what does it think about the value of the variable Bugs Bunny? It says it's 0. It's clearly in conflict with this. We have not executed any Python statement that would set this value to 0. Just to beat this to death, make it 1, 2, 3, 4. We're not going to do that. We're going to make it 31,337. If you haven't looked up that value by now and why it's funny, then I certainly suggest you start. There you go. Alright. So let's, before we jump into any of the crazy advanced stuff, is it crazy advanced? I don't know, that's subjective. But before we jump into any of the tools that we're going to use about Cheat Engine, let's define in a strict, or in a somewhat strict way, what is the goal that we're trying to accomplish by going through some of this stuff and whatnot. What we are going to do, or at least the mission statement that I'm going to set. Again, I haven't done this stuff before this video, or it's going to end up leading into a video or a second video, maybe even a third. What we're going to do is we are going to find a pointer relative to the start of this process so that we can, the first variable that we declare in this process, we will be able to find the value. Doesn't matter what the name is, doesn't matter what the value is, we will have some pointer down here that will just be a P hyphen right arrow to some address, and we will see the value sitting over here in the variable, similar to how we do now. And no matter whether we reassign this variable, remember, in the previous videos, every time we reassign the variable, behind the scenes, the black box memory manager of Python was destroying this variable, reassigning a new memory location, same name, but reassigning a new memory location with whatever value we're specifying here, and it was totally messing us up. We couldn't come up with some sort of coherent way to point Cheat Engine at a memory location that would reflect the value of the variable that we were screwing with over here. So again, let's go back, sort of revisit that concept. What are we going to do? We are going to make a pointer relative to the process, python w.exe, that is going to point us to the value of the first variable that we're going to declare when we start up this interpreter. If we start making 2, 3, 4, 5 variables, that's going to be an entirely different story, or at least we're putting forth the idea that that's going to be an entirely different story. Again, sort of making this up as we go along, but I'm pretty sure we can sort of solidify this concept. So really, how is that even possible? How is it possible that we're going to do that? It is possible to do that because the Python interpreter, as installed by the installer that we used in one of the previous videos, has it will never change what it's loading into memory. So it has a set of instructions and a set of logic and whatnot that it's going to load into memory, and it's going to refer to all sorts of logic rules and just an insane amount of data that it will refer to and reference and things like that and point to if you want to be crazy about it. But that set of data will never change. So whether we open up a new copy of it and we start declaring, when we declare our first variable, we're going to set the value to 0. It doesn't matter what we do, it's not going to reflect over here. This value, this first variable that we declare, occupies some amount of space in memory, and that space, that memory location where this variable starts, will always be the same relative to the start of where this Python shell is loaded in memory. Is it an absolute value? No, because as we've talked about, the process name, it could be loaded, sort of just at some random spot in memory, and when you type into Cheat Engine the name of the process, it is just substituting some absolute value in the why is that not working? Python w.exe, got a typo. I don't know. We'll do that. It's Python w.exe. Really? I don't know. It's really throwing a wrench, trying to screw me up here. But anyway, the point is, it's because we already closed it and it's not connected to a process. But anyway, the pointer that we're going to make is going to be relative to where this process, or the process that we connected to, is loaded in the absolute memory of the computer, and then we're going to establish offsets relative to the start of this process in memory, and with those offsets we will be able to sort of jump over all the crap that this program loads when it first starts up, and we will be able to say when we declare a variable, it's going to make space for that variable, and it's going to do it in the same spot relative to the start of this process every time, and we can use that to our advantage.